Let's do 4-3 number 5. Let's take a look. It says, assume that below A is row equivalent to B. Find bases for the null space of A and the column space of A. Okay, so here is our matrix A. Okay, and here is B. And remember, they're saying B is row equivalent to A. And it looks like B might be in reduced echelon form. Actually, just echelon form, not reduced echelon form. Okay, and notice that that's true because the first non-zero entry in the second row is to the right of the first non-zero entry in the first row. First non-zero entry in the third row is to the right of the first non-zero entry in the second row. And we have zeros all below those elements. Okay, looks like it's in echelon form. Okay, so I might start by finding the basis for the column space. And we've used this fact before. Remember, if you change this thing into echelon form, you just have to look at the pivot columns of the new matrix, and that'll give you an idea of what you can use for basis elements in the original matrix. Okay, for the column space. And it looks like the first column is a pivot column. Looks like the second column is a pivot column, and so is the last column. So that means we can use this column as one of the basis elements, this column is one of the basis elements, and this column is one of the basis elements. So the second part's actually a little bit easier, I think. This would suffice as a basis for the column space. And like I said, we've done that little trick before. You don't want to use the columns in the echelon form, but in the original form. All right, so that is a basis for the column space. All right, well, let's do the second part, which is to find, and I guess we'll call that part A and call this part B. We want a basis for the null space of A. All right. So remember, the null space just means you take your matrix A and multiply it by X and set it equal to 0. And then you find all the solutions of that equation. And if you can characterize that solution set, you can usually find a basis for that set of vectors. All right. But notice that if I do consider that system of equations, and think of this as a column vector of zeros here, this will be the augmented matrix for that system. It'll just be matrix A Well, the only difference is we have to add a column of zeros. All right. Now, they tell us in the problem that B is row equivalent to A. So they got to B by doing just a bunch of row operations to A. But notice we can do exactly the same row operations to this augmented matrix, and it's not going to change anything in this last column because they're all zeros anyway. So when we change this thing into echelon form, it's going to look just like B, except we're going to have a last column of zeros. All right. So you don't really have to go through a lot of trouble. Just write down B, but just insert an extra column of zeros. So that would be the augmented matrix in echelon form. Okay, and I suppose we could continue and change this thing into reduced echelon form. So I suppose to do that, we should divide the second row by 2. And I'm going to divide the third row by -4. That might do it. Well, not quite. Because notice this is a pivot column, this is a pivot column. All the elements that aren't 1s are 0s, but this is our last pivot column, and we need to get rid of this element and this element. Okay, so we're almost there. So I'm just going to say negative row 3 plus row 2. And then -7, row 3 plus row 1. So that is in reduced echelon form. All right. So now we should be able to characterize the solutions. And I'm talking about the null space of A. So it looks like one equation is x1 equals -2x2 minus x3. Another equation is actually that's an x4, isn't it? Because that's 1x1 plus 2x2 plus x4. That should be an x4 there. The second equation is x3 equals x4, looks like. And the next equation is x5 equals 0. So it looks like the basic variables are x1, x2, and x1, x3, and x5. And the basic variables are x2 and x4. So that looks right. Almost done. Okay, so let's characterize the solutions in a way that will allow us to determine the basis of the null space. So I always like to write it as x1, x2, x3, x4, x5 first. And x1 is really just -2x2 minus x4. x2, we're going to leave it the way it is since it's a free variable. x3 is x4, and x5 is, I should say x4 is just x4, and x5 is 0. All right. Now, let's factor out the x2. And then we'll factor out the x4. So these ought to be basis elements. And you can check, clearly these two vectors span the space because the space is just a set of linear combinations of those two vectors. So that part is satisfied. And you can check and make sure they're linearly independent if you want to, but I know they are because that's a 0 and that's a 1. But this ought to be your basis for the null space.